Hello everyone, I am Dr. Mo Shiva, Professor of Electrical Engineering at California State University, Fullerton. I have already posted several examples for mesh and nodal analysis. I have 3-4 nodal analysis, 3 videos for mesh analysis. If you haven't seen those already, please go and review those to get familiar with nodal and mesh analysis. The purpose of this video is just to see if nodal or mesh analysis is our best choice. Nodal and mesh analysis are general methods that we can use to analyze circuits. However, rushing and using them is not wise. Look at the circuits carefully, see if we can simplify them, and then decide on what steps and what method to use to solve the problems. To do a couple of examples, here the unknown of the problem is Vx. So for the sake of argument, if you want to do, let's say, mesh analysis, we have 4 meshes, ending up with 4 equations and 4 unknowns. So before rushing, let's simplify the circuit a little bit and see what we end up with. So we have a power supply on the left side. Let's start with that. 240 volts. Top of that is connected to an 8 ohm resistor. Following that, we have these 3 resistors, all starting at the bottom of 8 ohm resistor and going back on the other side to 12 ohm resistor. So these 3 are right here. 60, 40, and 48, connected to a 12 ohm resistor and going back to the source. Also, positive of the source is connected to a 24 ohm resistor. And the other side of that resistor is also connected to the 12 ohm resistor. Vx is defined across the 24 ohm resistor. So to simplify, let us combine these 3 resistors into, let's call it R equivalent. Connecting 3 resistors in parallel. 1 over Req is equal to 1 over 60 plus 1 over 40 plus 1 over 48. Take 480 to be the common denominator. We have 8 plus 12 plus 10. 30 over 480, or 1 over 16. So that tells us the equivalent resistance is 16 ohms. So we can simplify the circuit now. What we have there is the source, on the top it goes through, it's connected to an 8 ohm resistor. Below that we have our equivalent 16 ohm resistor. To the left, 12 ohm resistor and back to the source. On the right hand side, 24 ohm resistor and voltage across that is voltage of interest. Now, Vx is the voltage drop from top to the bottom of these resistors. If we combine these two in parallel, we are looking at 16 plus 8 parallel 24. This is 24 ohms parallel to another 24 ohms, and as you know, it will be 12 ohms. So simplify a little bit more. We are looking at 240 volt source on the top connected to 12 ohms. Vx is right across that. That is connected to another 12 ohm resistor and back to the source. We are looking for Vx. Now from this figure, Vx is doing a voltage division, 240 times resistance of interest, 12, over summation of the two resistors. In other words, split it across 12 and 12. Obviously, half of it is on the top, 120 volt, and that's the answer. We don't have to do mesh analysis. We don't have to do nodal analysis. Nothing of that nature. Let's look at another example. Here again, we have three meshes. Before rushing, let's simplify the circuit. We're looking at a source 4.88 volts. Positive of that is connected to a 7.8 ohm resistor. Also notice that the numbers here, 29.87, 15.6, 4.88, they are not whole numbers, so we will have decimals in the equations. 7.8 is connected to a resistance of 15.6 ohms. And another 15.6 ohm resistor, where Vx is across that. And the bottom side of those is connected to the source. Top of the source is connected to a resistor of 29.87 ohms. And that's also connected to the negative of the source. So that comes right here. 15.6 parallel 15.6 results in 7.8 ohms. So the simplified circuit now is 4.88 volts. Connected to two resistors, 7.8 ohms each, Vx is defined to be the voltage across the lower resistor. And also on the right hand side we have a resistor of 29.87 ohms. Notice that between these two nodes the voltage is controlled by the source, and 29.87 has nothing to do with that. I have two resistors of 7.8 ohms equal, so Vx is simply half of the source voltage. Again, simplify the circuit, look at the result, and then decide on what method to use. Just rushing into mesh or nodal analysis may not always be the best solution. Look at my other videos regarding different techniques for analyzing circuits. Thank you.